Hi, everybody. Well, hopefully this works. Hopefully this recording comes out okay. If it's not, you guys just tell me so I can fix it. I don't know where the microphone is on my computer, so I don't know really where to talk into. So last video I made the sound came out a little blurry. Hopefully this doesn't do the same. So last we left off, we were starting. We had just started talking about a standard normal distribution. Now, standard normal distribution is not something that applies to all types of data, but it does apply to some certain things. Things that are normally distributed are things like IQ, height, how tall people are, things like that, and things that pretty much all have the same mean, median, and mode. So if you guys remember when we talked about, mean was your average, your median was your number in the middle, and your mode was the number that was most often. Typically, when things have the same mean, median, mode, they are normally distributed. Okay? So what does that mean? So for something like height, which we're going to talk about, the average height for men in the United States is 70 inches. That's 5'10". That means that the average height, the mean height of men in the United States is 70 inches. It also means the median height, meaning if you took all of the information, split it down the middle, 70 falls in the middle, and that it's also the number that occurs the most time. Okay? So whenever we have a standard normal distribution, that is right here in the middle. And notice that that's our highest point in the graph, meaning that's the number that occurs the most. There's some numbers that occur less than that, and there's some numbers that occur more than that. Okay? So the next thing you'll see is this symbol down the bottom. Don't be alarmed. This is sigma. This is the Greek letter sigma. It's lowercase sigma, believe it or not. Uppercase sigma, we learned about already. So maybe not all of you. Some of you guys learned about it already. If you were in my class for more than a year. But yeah, it's a standard deviation. Okay, and what that means is a standardized distance from the mean, so from 70. So for the height of an American male, the standard deviation is 4 inches. So that brings us up one standard deviation above would be 74, so the 4 inches plus, and a 4 inches minus, well, 70 minus 4 would be 66. Okay? Now, what does that mean for us? Is that 34% of men in the United States are between 70 and 74 inches. In other words, from about 5'10" to 6'2". Another 34% are from about 5'6" to 5'10". That makes up a majority of the United States. If you think about most people that you know, most grown men, I should say, that is absolutely true. Yeah, that's about 68.2% altogether. I believe I brought that one up. Yes, actually, these numbers are a little more fun. We were estimating there. Yes, and most of them fall within one standard deviation. Okay. So again, I'll write this was 5'10". This was 6'2", and this was 5'6". Okay. Now, if we want another standard deviation, that'll get us to 78 inches, which makes 6. And then going down one more, we'd be 5'2". These are people who are tall and short, right? They make up a less population. They only make up about 13.6% each. So about 13.6% of the population is between 6'2" and 6'6", and about 13.6% of the population is between 5'2" and 5'6". If you think about that in terms of overall numbers, that's 95% of your population. Now, I know that seems a little crazy, but we're talking about a pretty big spread here, right? We're talking about between 5'2" and 6'6". That's that's over a foot. That's a big spread, but that's where most of your people fall. Now, if you go outside this, we'll go one more standard deviation. That's from 82 inches. Okay, that's here, and that would make you 6'10", and down here that would make you 4'8". Now, listen, I don't know about you guys. I am very tall, and I am, sorry, let me put these down here. This was 62, and this was 58, I believe. Yeah. I don't know about you. I don't know anybody who's 6'10". I'm not 6'10". Most of you guys, I'm really tall, and I'm not 6'10". 4'8" also makes you exceptionally short. Okay. So inside this range between 4'8" and 6'10". So again, that is 3 standard deviations down and 3 standard deviations up. That is an overwhelming majority of people. That is 99.73% of your people. That's just about everybody. Anybody outside this represents the other about 0.25%, right? Okay, that is a very small amount of people, and again, those are the people who are, again, 6'10", 7'2". These are your NBA players, and down the other end, these are your people who are under 4'8". Okay, so these are you're probably not looking at someone you're meeting on your average day. These are people that occur very, very rarely. Okay, so long story short, for today, your mean is going to be the number that's right in the middle. Okay. When we go up or down standard deviations, typically you'll be given the number. We'll talk maybe about how to calculate standard deviation at some point. And then what we can do is we can make estimates based on the population based around these numbers. Okay. So I posted a video up on your worksheet up on the website. It looks like this: standard normal distributions. Okay. Let's talk about up here. Okay, for your first one, it says a set of data with a mean of 45. Okay, so what does that mean? It means your mean is 45. Okay. It should have a standard deviation of 8.3. So again, what's 45 plus 8.3? Well, that's going to be 53.3. So this next one up here will be 53.3. So one standard deviation is going to be 53.3. Going up again, another 8.3. You will get 61.6. Sorry about the marker. It's not the best tool. Okay, and my third standard deviation will be another 8.3. So you get 61.6 plus 8.3 is going to be 69.9. Now, they didn't tell us specifically what this information was. CC, you want to say hi? You want to say hi? You shake, they can't see you shake your head no. Just say hi so they know I'm not talking to myself. No, you're not going to. Well, say something. They think I'm talking to nobody. I swear to you, there is a 6-year-old girl standing right next to me right now. 6? She's kind of tricky in saying that you are 7. Comfortable. Okay, I'm not talking to myself. I swear my niece Cecilia is here with me. She's just getting very, very shy and says, if my nephew comes back in, I'm sure he'll yell and scream. Okay. He likes to talk. All right. Now, going down the other way, going down. All you gotta do is take your mean and subtract 8.3 going the other way. Okay? 45 minus 8.3 is gonna be 30. Oops. 36.7. Okay, and if I subtract another 8.3, not 28.4. 28.4. If I go one more. Oops. Minus 8.3. Okay, we get 20.1. Does this show you? No? Okay. So, again, these are your numbers, okay? Also, by the way, because any numbers outside of that, because you're at, 0.1%, 0.1% for everybody else. Unless your population is really, really big, okay, unless you're talking about a large group of people or things like that, you're probably not going to have anybody there. If according to this graph that makes up, 99.73% of people, unless you have 1,000 people, you're not going to have anybody there. Even if you only had 100 people, most of your 100 people are going to fill right in here. You might have one person outside, and that might be upper or lower. Okay. So those are your numbers. So let's answer some of these questions. It says, what's one standard deviation above the mean? Okay, so one standard deviation above the mean. So here's my mean. Here's one standard deviation is going to be 53.3. Good. 3 standard deviations, plus 3 standard deviations from the mean. Again, let's select our notes. We're going 1, 2, 3 standard deviations from the mean. That will be 69.9. Okay. What's down 1 standard deviation from the mean? We're going down 1, and we've got 36.7. Okay, and what's down 2 standard deviations from the mean? Question number 4 is going to be 27.4. You're still going to pretend not to be standing next to me. You're dropping ping pong balls across the laptop. Good job, Cece. Here. The second standard deviation is going to be 28.4. All right, that's for 28.4. I can hear you giggling. Okay. Good, so you can fill those numbers in. I'm going to do one more on the next page, and I'm going to expect you guys to kind of be able to do the rest of them. Okay. So for this one, it asks you to label the normal distribution curve. Okay. All right. So sketch normal curve for each distribution. Label the x-axis. 1, 2. You're still not going to talk to them and tell them, hold on. No, you're just going to sit there and giggle the entire. Great. Okay. So your mean goes right here in the middle. Your mean is going to be 95. Okay. So again, 95 plus 12. Your standard deviation is 12. Plus 12 is going to be 107. Plus another 12 would be 119, and then another 12 on top of 119 would be, hey, CC, what's 119 plus 12? What, they teach you that in kindergarten? Okay, and 119 plus 12 is going to be 130. Okay, so again, what are you going to do? You're going to start with your mean, and you're going to add this number, add it again, and add it a third time. Okay, going down the other way, we're going to subtract 12. 95 minus 12 is going to be 83. Minus another 12, 83 minus 12 is going to be 71, and 71 minus 12 is going to be 59. Okay? So again, what are you doing? Starting for your mean, plus 12, plus 12, plus 12, and then minus 12, minus 12, minus 12. Okay? Good? I'm going to do one more. I'll show you guys, and then I'll leave it up to you guys. Okay? You guys can handle this. You can use a calculator if you guys feel comfortable, if you want to make sure your numbers are right. So again, here our mean is 100. And our standard deviation is 15. So 100 plus 15 is 115. 115 plus 15 is 130. And 130 plus 15 is going to be 145. Going down the other direction, 100 minus 15 is going to be 85. Minus another 15 is going to be, was it 60? Oh, sorry, 70. And minus another 15 is going to be 55. Okay, so why don't you guys go ahead and do the next 7, 8, 9, and 10, and we'll talk about tomorrow how we're going to go ahead and apply this. So thank you guys for watching. Let me know if you have any questions. I mean, this is just pretty much adding and subtracting. So even if you don't totally get the concept of the normal distribution, that's okay. It'll kind of come to you as we go through it. But I'm pretty sure pretty much everybody in the class can start with a number and add the same number 3 times and subtract the same number 3 times. Okay. So anyway, I'll talk to you guys tomorrow, I guess. Hey, Mike, Cece, you guys want to say goodbye? You want to say goodbye?
Bye-bye. I